Hey guys, welcome back to the second mini lecture on the autonomic nervous system. All right, recall from last time that we have a sympathetic and a parasympathetic division. They are exhibiting something known as dual innervation. What that means is that, for example, the heart is going to receive both sympathetic and parasympathetic neurons. So it's innervated by the two different groups. Why do we do this? Well, by having both branches innervate the same structure, we can have one that is going to stimulate it and one's going to inhibit it. Now, why would we do that? We would do that so that we can maintain homeostasis, of course. All right, so that's dual innervation. And that we sort of hinted at this idea already. Dual innervation allows for antagonistic control. So for example, sympathetic neurons, when they stimulate the heart rate goes up. Parasympathetic, when those neurons release neurotransmitters onto the heart, they inhibit the heart rate goes down. So by having one branch that increases heart rate and one branch that decreases it, we are better able to control it. And controlling heart rate or controlling anything in our body, any physiological parameter, is going to be homeostasis. So we got dual innervation, which leads to antagonistic control, which lets us do homeostasis. All right, we already met a nickname earlier for the parasympathetic division. That earlier nickname was the fight or flight division. Another nickname for the parasympathetic division is the D division, because three of the major things that parasympathetic system is involved in start with the letter D. I'm talking about digestion, defecation, and diuresis. I took a picture of my lunch today. Usual Tuesday lunch, lobster tails, steak, a little bit of butter, lemon. It's fantastic. And the parasympathetic division helps you digest it. Later on, if you're pooping, that's parasympathetic as well. Diuresis is peeing. So we got basically eating, processing, pooping, and peeing. P, processing food, pooping, peeing. D, digestion, defecation, diuresis. All right, the sympathetic division has another nickname. It's the E division, because this division is active when you're excited, when you're exercising, when you're embarrassed, or when you are in an emergency situation. So this is why it's called the E division. All right, more nicknames. The parasympathetic division is also known as the craniosacral division. Because if we look here, the parasympathetic neurons are coming out of the brain and then coming out of what's going to be the sacral portion of the spinal cord. Whereas the sympathetic neurons begin in the thoracic and lumbar cord and are thus known as the thoracolumbar division. Okay, good. Let's contrast those pathways a little bit more. We did this already, but we're going to do a little more. Both the sympathetic and parasympathetic pathways are going to be two neuron pathways. The initial neuron starts in the CNS, in the brain or cord, and extends outward to a ganglion. Now, our first neuron, notice this middle word here. Our first neuron is called a preganglionic neuron. Preganglionic neuron, because it is before the ganglion. Notice that this neuron is also said to be cholinergic. Cholinergic means it releases acetylcholine. So fairly similar here, except in the sympathetic pathway, the first neuron is short. Parasympathetic pathway, first neuron is long. So that means the ganglion is closer to the CNS for sympathetic and farther for parasympathetic. Now, our second neuron extends from the ganglion all the way to the target, to the effector. Remember, cardiac muscle, smooth muscle, glands. Our second neuron for the sympathetic pathway, it's called the postganglionic neuron because it's the one after the ganglion. Down here as well, look, postganglionic right there. Now, our sympathetic postganglionic neuron is also known as the adrenergic neuron because it releases norepinephrine onto its target tissue. The parasympathetic postganglionic is cholinergic, like the two preganglionics, because it is going to release acetylcholine. And notice that the sympathetic had the short one first, long one second. Parasympathetic, long one first, short one second. Okay, let's look at the pathway for how parasympathetic neurons get out of the brain and the spinal cord. Here we see that there are 4 cranial nerves leaving the brain carrying parasympathetic messages to either glands or smooth muscle or cardiac muscle. Now, cranial nerve number 3, remember that is the oculomotor nerve. It is going to go to the smooth muscle in the pupil of your eye, the smooth muscle affecting the lens of your eye as well. Notice we have our 1, 2 neuron pathway. Cranial nerve number 7. That's the facial nerve. Facial nerve is going to go to basically almost all the glands of your face, all of them except for the parotid. So we're going to the lacrimal glands for tears of joy, nasal glands for snot production, and to the submandibular and sublingual glands for saliva production. Cranial nerve number 9, glossopharyngeal, goes to the parotid gland. Cranial nerve number 10, that's the vagus nerve. Remember, it goes down to the thoracic and abdominal cavities. So it is going to go down to the cardiac muscle in the heart. It's going to go down to smooth muscle in the lungs. Plus, it's going to go to other abdominal organs like the liver and gallbladder, glands and muscles there, and the glands and the muscle in the stomach, the glands of the pancreas, the glands and the muscle of the intestines as well. Now, the sacral part, remember parasympathetic is cranio, that was the brain part, and sacral. The sacral part, from sacral segments S2 to S4, we're going to the urinary bladder for diuresis, for peeing, to the rectum for defecation, for pooping, and also to the male and female genitalia. And we'll talk about what happens there later on in a future mini lecture. Okay, that pretty much does it for our parasympathetic pathway. The sympathetic pathway is going to be more complicated because we're going to go to more organs. We're going to abdominal and thoracic viscera. We're going to sweat glands. Sweat glands are everywhere. We're going to arrector pili. Remember, those are the little ribbons of smooth muscle that cause the hairs to stand up. And those are all over your skin. And then also we're going to vascular smooth muscle. So I'm talking about the muscle in arteries and veins here. And that is also everywhere. So we have a lot more places to go. And that means we're going to have a bunch of different pathways. And we're going to look at all those pathways. To do that, though, we're going to have to start with some anatomy review. And I think we'll pick that up in the next mini lecture. See you later.